Okay, so we're in part 2. So let's go ahead and continue on with example number 6. Find each of the following if it exists. If the value is undefined, write undefined. So example number 6. A, we have sine negative 270, which is the same as sine of, if I add 360, what do I get? 90, right? Okay, which is going to be equal to, in radians, what is this? Pi over 2, because it's half of 180, right? Pi over 2, and this is going to be equal to 1. Okay. Then we have B, which is tangent 3 pi. Tangent 3 pi is the same as tangent of, if I subtract the 2 pi away, the same as tangent pi, right, which is the same as sine pi divided by cosine pi. Sine of pi would be what? 1, 0. 1, negative 1, 0.
It's negative 1.
0, it is 0. Okay. Cosine pi is negative 1. 0 over negative 1 is 0. Secant 11 pi over 2, which is the same as 1 over, what is the secant, the reverse of the reciprocal of? Cosine 11 pi over 2. Now I can subtract what? I can subtract some pi's off of this, right? Right? If I subtracted 4 pi's worth, what do I get?
7.
It'd be 3 pi over 2, right? 11 pi over 2 minus 4 pi, which is 2 over 8, right? Which is 3 pi over 2. 3 pi over 2 is what in degrees? 270. 270. Okay, so the cosine of 270 is
0.
No.
1, negative 1, 0.
0.
1 over 0. You are not allowed to do this. Undefined, right? Undefined. Okay. Example number 7, using one trig ratio to find the other. So this is where it gets a little dicey. They're going to give you the hints in several different ways. Okay, so let's see what we have here. First one, A, 7. A, we have sine theta equal to 3 over 7. And tangent theta is less than 0, and they want us to find what? Find cosine and tangent theta. Okay. So, sine theta is 3 over 7, which means it is a positive number, which means that the theta can be what quadrants? Either quadrant number 1 or 2. Right? Sine is positive, positive, negative, negative. Right? Positive, positive, negative, negative. So this could be for quadrant number 1 or number 2. But I know that tangent theta is less than 0, therefore it must be a, in which quadrant?
2 and 4. 2.
2, right? Because you have choices 1 or 2, right? But in quadrant 1, tangent theta would have been positive. So it must be quadrant number 2. So it's quadrant number 2, and we're supposed to find what? The cosine and the tangent, right? So, I mean, basically it's the 7 and 3, right? And this guy would have been 49 minus 9, 40 to 10. Okay. So the cosine, since it is second quadrant, is going to be negative. Right? It's going to be negative 2 root 10 over 7. Right? Tangent theta is going to be negative also, since it's in the second quadrant. This guy over this guy. Right? Get that? Makes sense? B. Secant theta is equal to 3. Again, we're going to do secant theta is equal to 3. We also know that sine theta is greater than 0. So what does this mean here? What can I conclude from this? Cosine theta is equal to 1/3, right? Cosine theta is greater than 0. Sine theta is greater than 0. Yes, so it must be fourth quadrant, right? And they want us to find the cosine value and the tangent value. Cosine 3, 1. So this guy must be 9 minus 1, 8, 2 root 2. So I found the cosine value. All I need to do is find the tangent value. And positive, it is this guy over this guy. 2 root 2 over 1. 2 root 2. Right? I know I'm coming at this pretty quickly here, pretty rapid fire. You just gotta be agile. You have to follow us. Right? You understand what's going on right now? Until now? Are we good? Are we good? I'm going a little quick. So, okay, so then we have cotangent is undefined and secant theta is negative. So C cotangent theta is undefined. And I also know that secant theta is negative. Secant theta is negative. Cotangent theta is what? It's basically 1 over tangent theta, which is 1 over sine theta over cosine theta. I'm going to multiply cosine theta on top and bottom. I get cosine theta over sine theta. And this is undefined, which means what? Sine theta had to be 0. So sine theta is equal to 0. But I also know that this is 1 over cosine theta is less than 0, which means that cosine theta is less than 0, which means that it's going to be either quadrant. Which quadrants can it be in? 2 or 3. 2 or 3, right? Okay. So what does this tell us? It's going to be 0, so it's going to be here on this side, right? So theta is basically pi. And I want to know what the cosine value is, cosine pi. And I want to know what tangent pi is. Cosine pi is going to be -1. tangent pi is going to be equal to 0 over -1, right? Sine pi over cosine pi. I'm going too fast. This is the same as sine pi over cosine pi. Sine pi is 0. This is, we just said was -1. Okay. It's kind of like a mystery Sherlock Holmes clues. They're giving you these, and you have to kind of figure out which quadrant we're in based upon whatever they're giving us, and then solve the rest. Okay, example number 7, we're good with that. Okay, so let's go to now page 344, and we'll talk about the unit circle. The unit circle is where kind of everything comes together, where we actually have a radius of 1, and that is exactly why it is the unit circle. And what happens when the radius is 1 is that we now have a situation. Since this is 1, if I had this theta, right? My x value here is going to be r, the radius times cosine theta, correct? So basically, I'm going to end up with cosine theta as being my x value. Okay. Y value is this guy here, the height here, right? This height here is going to be my y value. And that height is going to be sine theta, right? 1 times sine theta, so it's going to be sine theta, right? So just as you said, x is always going to be the cosine value, or the y is always going to be the sine value, okay? So you can actually track as the angle goes up what's happening to the y value. Okay, so let's look at the y value here. So look at the y value. This is why we're always positive. The sign is positive, sign is positive. Sign is still positive because it's the y value. Sign is positive, sign is positive. Now sign becomes negative because the y values are negative. Sign values are negative, sign values are negative. So sine is positive first and second quadrant, negative third and fourth quadrant. Whereas cosine is the other way around, right? Now we're looking at x. So cosine value, positive, positive, positive. Now it starts to become negative. Now the x value is now negative here. So cosine value is negative, 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 negative until here it becomes positive. Tangent value, always consider tangent as sine theta over cosine theta and just kind of track it as a result of what's happening to the other two. Okay, this is why the unit circle. Okay, so let's say, again, so I tried to explain this earlier when we were doing 4.2. Let's try it again. Okay, if I rise here, okay, there are 3 values that are really of whatever interests us, right? It's going to be the 30, 45, and 60, right? Always. Okay, so 30, 45, and 60. 45s are always going to be 1 over root 2, right? Which part? Always going to be 1 over root 2. Now the 30, or the pi over 6, the y value, let's look at the y value, okay? So the y value, the first value of interest I'm going to hit is pi over 6, which sine value is 1/2. Then I'm going to hit 1 over root 2, which is basically 0.707. And the next value of interest I'm going to hit is going to be where it's 60, which is root 3 over 2, which is 0.866. So in other words, it's going to go from here to 1 pi over 2, and it's going to hit here. This is going to be 1, right? The first value it's going to hit is going to be at here, 1/2. Next value here, so this was pi over 6. It's going to be pi over 4, which is 1 over root 2. then over here, it's going to be √3/2, which is going to be pi/3, okay? And as it's going down, it's going to hit those three values again, right? So in other words, it went from here, y value is going up, increasing, 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 increasing. It maxes out here, and it's going to decrease, decrease, but it's going to follow through those three values again, okay? All right? And you can actually do the same thing for the cosine. Okay, the cosine is going to look at the, you're going to look at the x values, right? So it's going to be maximum here. It's going to be 1 because the sine, because right here is 1, right? This is 1. The x value is 1. It's going to start to go down to here to 0 because the x value here is 0. And then the x value is -1, 0, and then back to 1. So the cosine graph starts at 1, goes to 0, -1, 0, and 1. Right? Okay. Again, it's going to follow, it's going to float through the three specific values, right? It's going to hit 1/2, 1/√2, √3/2, and it's going to continue on and do that thing all the way. Okay. So let's go to page 344. There's a blue box that says a unit circle is a circle of radius 1. And then there's a blue box on the bottom of page 344 also that you should read. You should be okay with that one. There's a periodicity there. So we talked about that. You can subtract, you can add and subtract 2 pi's on that. So let's go ahead and kind of quickly look through that one. We haven't talked about that. And then on the very bottom of page 246 is your grand final result, the 16-point unit circle, which is basically a review for you. You've done this before. You actually made very pretty little projects for Miss Rasmus also, I think. Did you not? Or you did? No.
Yeah.
You've never done the unit circle. Okay. I thought she used to do that all the time. I guess she stopped doing it.
Well, what class was she in?
Algebra.
The Berkeley Algebra one.
Huh?
What?
No. Of course not. Okay. Right, whatever. Okay, so let's do example number 8. Example number 8. A. I have sine a huge number there, 57801/2, is it?
Yeah.
This many pi's. Okay. So when I look at this, so what I'm going to think, the way I'm going to look at this is going to look at it like this. I'm going to go ahead and say this is can I do that? These are all multiple, this is a multiple of 2 pi's, right? Right? This is kind of useless to me, right? This kind of just goes away. All I'm left up with is this. Sine pi/2, which is 1. And the second one is kind of the same thing.
How did you do that with that?
Huh?
How did you do
Pi/2, 90 degrees. Sine 1. 288.45 pi minus cosine 280.45 pi. Do the same thing here. This is cosine 288 pi plus 0.45 pi minus cosine 280 pi plus 0.45 pi. These are all multiples of 2 pi's. I mean, it just goes away. This guy goes away. Big fat nothing. They're the same thing, right? And then cosine 0.45 pi minus cosine 0.455, 0. And then last but not least, I have tangent of pi over 4 minus 9999 pi. Oh, there's one more 9. What the heck? All right. Okay. So I can add multiples of 2 pi's here, right? Right? So this ends up being so this will be the same as tangent 5 pi over 4. What quadrant is this? Quadrant number 3, which means that tangent would be
Negative. Positive.
positive because sine and cosine are both negative, right? It's sine divided by cosine, right? So it's negative divided by negative. This will be a positive number. 1 over root 2 over 1 over root 2. It's actually negative 1 over root 2 over negative root 2, right? Because sine of 5 pi over 4 is 1 over negative 1 over root 2. It's negative 1 over root 2 over negative 1 over root 2. All right, we are done for the day.